Hi, welcome to Unit 6, Day 5. This is our lesson over using similar right triangles. Starting off, this uses the geometric means that we've talked about in previous sections. So if you need a refresher on that, Khan Academy on geometric mean is a good place to go to if you're struggling with setting things up for this particular section. Starting off, Theorem 7.5 talks about how essentially we've got this right triangle right here, and if you notice this dashed line between point C and D, we can split that up because we have another right angle here. And so essentially what we have is that these three triangles are similar. Talks about triangle CBD is similar to triangle ABC, and it's helpful as you go through and do this is to kind of follow along. Triangle CBD, so this is the small triangle, is similar to triangle ABC. So that's kind of the large triangle. I'll refer to these as small, medium, and large as we go through. Notice that there is a right angle on each, and then across from the right angle is the hypotenuse. So make sure you're also noticing that as well. Down here below, just to kind of follow along with what we just said, it says identify the similar triangles in the diagram. So I think it's helpful to first draw the largest one. So on this one here, it says sketch the three similar right triangles so that the corresponding angles and sides have the same orientation. So I'm going to start with this largest triangle. And the largest triangle is triangle STR, RST. I usually go in alphabetical order. So looking at this largest triangle, we've got something that looks like this. And so notice that this is the orientation that then all of the other triangles we need to follow. That's point T. T corresponds to the right angle, S, and then R. So now I have two other triangles. Let's do the smallest triangle. So again, it has to have the same orientation. The smallest triangle is this triangle right here. So this is the triangle with this right angle at U and then S and T. Well, because the right angle is at U, this is really helpful. So the right angle is at U, point U. And then from here, from U to S is the smallest length. From U to S is the smallest length. And then the only other point that we have left then is T. So that would go there. So that's point T. And then the medium triangle. Oh, forgot to include the right angle there. And then also right angle here. So the medium triangle is the triangle with U, T, and R. Again, U is my right angle. So U goes here. And from U to T now is the shortest length. And then T to R. Notice T to R is across from the right angle. So T to R is the hypotenuse. It's also the longest length there. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments, and the length of the two segments is the geometric mean. So what we have is the length of the altitude is the geometric mean of the length of the two segments. So the length of the altitude, so that's length CD. So what we have then for the geometric mean is the relationship the length AD, over the length of CD is equal to the length of CD over the length of DB. You will also see this referred to as segment 1 over the altitude is equal to the altitude over segment 2. So applying this here in the bottom, in a right triangle, the altitudes from the right angle to the hypotenuse divides the hypotenuse into two segments. So this is segment and segment. So we call this segment 1 and segment 2. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. A lot going on there, but essentially we have another geometric mean, and that's this one here. So if I go from A to B over A to C, then that's equal to A to C over A to D. It's just another way of setting up what we just said. If I think about that, that's the hypotenuse over the leg is equal to the leg over the segment. So we'll be using these in the examples on the back. Flip the page. So here I have example 2. Setting at the top, I have x over 12 is equal to blank over 8. So if setting up from the proportion from the previous page, I know that 12 is the altitude, so that 12 is the altitude that needs to go here as well. So we set this up just like we would any other problem where we cross multiply x times 8. So 8x equals 12 times 12. 12 times 12 is in fact 144. So if I divide by 8 on both sides, you get x equals 18. As always, if I'm going too fast, please pause, slow down so that you can write out, and then just feel free to resume as you need to. B, this one, 15 over x is equal to x over blank. Now, to get this one, we actually need to know this missing value here, that length. We know the length of the whole, it's 20. We know the length of this part's 15, so 20 minus 15 will give us 5. And that is what our missing value goes in there. So to find out what the x value is, we cross multiply. So 15 times 5 equals x times x. 15 times 5, 75. X times x is x squared. So I take the square root on both sides to eliminate the squared here. Then I have x equals the square root of 75. 75, there's a perfect square that can come out of 75. Perfect square out of 75 is 25. So if I split up the square root of 75, I will get x equals the square root of 25 and the square root of 3. And the square root of 25 we know is 5. So x equals 5, square root of 3. Next one, letter C. This one, we've got length. So we have this length of 9 over x equals x over blank. This one is an example of kind of that last one that we're talking about. This one we actually need to know the length of the entire hypotenuse here. So knowing that this is 9 and this is 11, we can add these together and we get 20. Cross multiplying, we get x times x, which is x squared. 9 times 20, which is 180. Square root both sides, so we get x equals square root of 180. When we split up 180 into its perfect squares, let's see. 4, there's a bigger one. 36. 36 times 5. Helps to have your calculator ready. Don't be like Mr. Brummond. Have your calculator ready to go. Yep, 36 times 5. All right. X equals the square root of 36 times the square root of 5. The square root of 36 is 6, so that gives me 6 square root of 5. Those are the top examples. Examples 2. Examples 3. So same idea, still finding the value of each variable. This one here, we're trying to find this part here, and that is a leg. So to find the leg, setting up my proportion. So this one, they didn't set up the proportion for me. I need to set up the proportion. So in this one, I will have 12, that's the hypotenuse, over 6 is equal to 6 over a. Cross multiply. 12 times a. It's 12a. 6 times 6 is 36. Divide by 12 on both sides, and you get a equals 3. Letter B. This one we're finding the altitude. So to find the altitude, we have 6 over x is equal to x, the altitude, over 8, the other side. Segment 2. 6 times 8 is 48, and x times x is x squared. I'm just going to reorient them so that x squared is on this side. 6 times 8 is 48. Square root both sides. And we get x equals, let's see, I think square root of 16 times square root of 3. Yep. And then I get x equals 4 radical 3. That's B. C. This one, we're finding the length of this segment. We're given the hypotenuse and this leg. So setting it up, we'd want 24 over the leg, which is 10, equaling 10 the leg over the shorter side, which is B. This will give me, let's see, 24B, cross multiply 24 times B, 24B, 10 times 10 is 100. Divide by 24 on both sides. Let's see, that reduces down to 4, so it looks like it's 25/6. Yeah, looks like 25/6 is the exact value. Double checking to make sure I'm right. Yep. If you type that in your calculator, you get 4.16, and then the 6 repeats, just the 6. Then the bottom row. This one's a little bit trickier, just because we have the W plus 9 part. Looks like we're trying to use the altitude here. So we've got, let's see, 8 over W plus 9 is equal to W plus 9 over 18. 8 times 18, that's going to give us 144. This looks tricky because we're taking W plus 9 times W plus 9. But then what we're going to end up with when we do that is we end up with W plus 9 squared. So if you think about what's going to happen when we square root both sides, we're going to actually get rid of this squared and this square root. So it's going to come out to be really nice. Just a W plus 9 equals, and then the square root of 144 is 12. Minus 9 on both sides, and you get W equals 3. E my key has a different one for E and F. Oh, yeah, we changed it to make it a little bit nicer. Let me check this for a second. The recording will resume here shortly. All right, so you're not going to notice any delay because I cut out the delay. But my key that I had for E and F were totally wrong, so I had to redo them real quick. So to set up for E, what we have is we have 24 over, so this side here, over the leg, so 14 square root of 6, is equal to 14 square root of 6 divided by the length of the whole thing. Now be careful, the length of the whole thing is x, so we end up with 14 square root of 6 over x. Cross multiply, 24x equals 14 square root of 6 times 14 square root of 6 is 14 square root of 6 squared, which means we're going to take 14 squared and then square root of 6 squared. 14 squared is 196, and then times 6. So 196 times 6 is 1,176. Divide by 24 on both sides, and you get x equals 49. And then for the last one, what we have is 36 over 6 times square root of 85 is equal to 6 times square root of 85 over x. Cross multiply, so 36 times x is 36x. And then we take 6 times the square root of 85 squared, what you end up with is 36, so 6 squared times 85. If I multiply all those out, I get 3,060, divide by 36 on both sides, and you get x equals 85. Hope you have a wonderful day, and I will see you soon. Bye!